to the H2O channel. You are welcome again to my YouTube channel. We are going to continue from where we stopped in our previous class. Remember, we made a video last week on the answers to the question that came out in your JAMB mock 2024. And today we are going to continue from where we stopped. As you can see on the board, we have question number 7. We took 6 questions. So if you know you have not watched our previous video where we started answering this JAMB mock physics question, please do well to watch them. You can go back or you can search for it on our YouTube page to get it. Now let's quickly go into what we have for today. The prism used to produce a pure spectrum is called a dash. The prism used to produce a pure spectrum is called a dash. Remember, in refraction experiment, we can make use of a triangular glass prism or a rectangular glass prism. And again, you must have heard of the concept they call dispersion of white light. Dispersion of white light. Ladies and gentlemen, what does dispersion of white light mean? It is the separation of white light into components of colors called Röykbild. That is your 7 color. And how is this done? Very easy. If you have a triangular glass prism this way, by the time white light comes and falls on it, now this is your white light. When your white light enters your triangular glass prism, what is bound to occur is refraction. Refraction will occur because the light is coming from L into this glass. Okay, so the light is going to bend. When it bends, we call it the refracted ray. So what will further happen to this refracted ray? Now, because white light is made up of 7 colors, and the 7 colors are better called Röykbild, okay, which signifies red, orange, yellow, green, blue, indigo, and violet. Because these 7 colors are found inside white light, and then these colors of light do not have the same speed in glass. Remember, this is a triangular glass prism. The speed of all the light is the same in air. That is why they unify themselves as white light. But as soon as they enter this prism, their speed varies in the glass prism. So what we are going to observe is that the colors are going to separate. Why are they separating? They are separating by a process called what? Refraction. Please take note of this. If they ask you what is the cause of dispersion of white light, it is caused by refraction, because the light of different colors do not have the same speed in glass prism. So you are going to see that the 7 colors will emerge from here. Okay, they are 7 in numbers. You have red, orange, yellow, green, blue, indigo, and the last color is your violet. Okay, this is what we call the dispersion of white light. The one that have the greatest speed is your red. That's why it came out first, then followed by your orange. As you can see, they are arranged in order of reducing the speed in the glass, not in the air. That's why the red light emerged first. It happens to be the most energetic and the one that have the greatest speed in glass. Take note of it. So the separation of white light into the component of Röykbild is what we call dispersion. Dispersion is caused by what we call refraction. Please take note. It is not diffraction. It is refraction. Refraction causes dispersion. Dispersion means the separation of white light into components of what? Color. Now, when they are talking about a pure spectrum, these are the spectrum of white light. A pure spectrum means a unified spectrum. It means a spectrum that has one single wavelength or a monochromatic wavelength, where each of them will be distinguished from each other, not like they are mixed up. If you are looking for how this light can be distinguished from each other, what kind of triangular glass prism are we going to use? Is it the normal triangular glass prism? No. You are going to use what we call, take notes, please get your pen and your jotting material, take note of this. To produce a pure spectrum, write it down. You need a convex triangular glass prism. I repeat again, convex triangular glass prism. Some of you might not have heard of this before. What is a convex triangular glass prism? It is actually a prism constructed to produce a pure spectrum. In this prism, you have a convex lens here where the light enters from, and you have a convex spheres in here where the light will reach. Okay, by the time the light passes through the convex lens with triangular glass prism and passes from triangular prism to the convex lens, before it gets to the mirror or the screen receiving the light will be distinguished from each other. So let us check our option. The prism used to produce a pure spectrum is the dash. Take note, it is called a convex triangular glass prism. Like I said before, a pure spectrum is called a monochromatic spectrum. It means a spectrum that can be distinctive from each other. Okay, take note of that. Now let us go to our next question. What is the formula for bulk modulus? I know some of you are surprised because you actually failed this question. Some of you got it, but some of you failed it. So if you failed it, or you have anyone who have written JAMB, or you were not opportune to write a JAMB mock physics, please take note of this correction so you will not fail it in your next exam. Now let's take this question. Let's take the second question. Question number 8. What is the formula for bulk modulus? Many of us have heard of modulus before. Okay, there are 3 moduli of elasticity. The first one is called the Young's modulus. The Young's modulus. What is the formula for the Young's modulus? Very easy. It is equals to tensile stress. Please take your jotting material over tensile strain. That's Young modulus, okay? Like I said, we have 3 moduli of elasticity. 3 moduli. The first one is Young's modulus. The second one is called the bulk modulus, which is where the question is coming from right now. The formula for your bulk modulus is equals to your volume stress over your volume strain. Please take note of that. So while your Young modulus is based on tensile stress, your bulk modulus is based on volume, okay? Number 3, we have the shear modulus. Your shear modulus is equals to shear stress all over shear strain. Ladies and gentlemen, it is important for you to know right now that what is the formula for the bulk modulus? Is it shear stress over shear strain? No. Check the formula for your shear modulus. You have shear stress over stress strain. So the answer is not A. Is it tensile stress over tensile strain? No. Tensile stress over tensile strain is the formula for Young modulus, so it is not B. Is it volume stress over volume strain? Yes, the answer is word A. Okay, so these are the 3 moduli of elasticity. Please take note of this important note that all the moduli are vector quantity. Please, they are vector quantity. All of them are vector quantity, that is, they have direction, and their unit is Newton per meter square. The same with pressure and stress. Okay, but take note that moduli of elasticity, they are all vector quantity. Let's quickly go to question number 9. Now, question number 9 said a copper rod. Remember, we have a video on linear expansivity. When you to watch that video, please do well to go back to that video so you can get the full gist of linear expansivity. A copper rod 4 meter long, that's the original length, is 4 meter. When heated to 10 degrees Celsius, the change in temperature is 10 degrees Celsius. Expand by 0.2 meter. The change in length is 0.2 meter. What is the linear expansivity? Wow, so interesting. This is like a bonus to almost all JAMB students because linear expansivity means change in length over the original length times change in temperature. So what is our change in length? 0.2. What's the original length? 4. Change in temperature is 10, so we have 0.2 over 4 times 10 will give us 40. And what would that give us likewise? 0.2 over 40 we have 5 times 10 raised to the power. You are supposed to have this. You are supposed to have this per Kelvin. This is what your JAMB calculator will give you. So you convert to standard form by taking 1, 2, 3. Okay? You are supposed to have 0.005 per Kelvin. So if you convert to standard form, in standard form, you have 5 times 10 raised to the power of minus 3 per Kelvin. Wow, so interesting. The answer to this question is not D, it's not C, it's not B, it is what? D. I guess I have to check this again. 0.2 over 40. Okay, it's correct. Wow. So you have 5 times 10 raised to the power of 3. Our answer is what? A. Okay, let's quickly take a few other questions before we come to the end of this video. The energy stored in a string when a force of 300 Newton stretches the string from 30 centimeter to 30.5 centimeter. Question number 10. Let's quickly take this question. The first year, don't forget that this topic is under elasticity of solid. The force applied is F, and that will give us, I'm talking about question 10, solution to question 10. Please don't mistake this. Solution to question 10. Now, the force is 300 Newton. Okay? If the force is 300 Newton, this force was able to cause the object to stretch from 30 centimeter to 30.0 centimeter to 30.5 centimeter. So we get our extension, which is L2 minus L1. What is our L2? 30.5 minus 30. That will give us 0.5 centimeter. Please remember that we don't solve in centimeter, we solve in meter. So we have to convert to meter by dividing with what? 100. And that will give us 0.005 meter. Are we together? So we have converted it now from centimeter to what? To meter. Okay? Now, what is the formula that will be used to calculate for the energy stored in a wire or a string? Don't forget that there are 3 basic formulas that are used in solving problems involving the energy stored in a string in elasticity of solid. What are the 3 formulas? As you are watching this video, please be writing these formulas down because they are very, very important. You can use them to solve other questions that will come out in your exam. The first formula is energy is equals to 1 over 2 Ke squared. Your K is called your force constant. K is force or elastic constant. I'm not just solving the question for you. I'm using this medium to teach you in details so that when subsequent questions or questions that looks like the ones we are doing comes out, you will demystify it. So your K is your force or elastic constant and it is measured in Newton per meter. Please, your E is called extension produced. Extension produced. and your extension produced must be in what? Meter. That's why we have converted it from centimeter to what? Meter. The other formula that I also use to calculate for the energy stored is 1 over 2 F E. Your F is known as your force applied. You can call it the force applied or you call it the load. And the load is measured in what? In Newton. Okay? The third formula is energy is equals to F squared over your 2K. So there are 3 formulas here that are used in gogodizing problems involving the energy stored in the string. Please take note of these 3 formulas. They are very, very essential. As for this particular question class, we are going to be using which formula? The formula to be used is determined by what is given to you in the question. If you watch, they gave us the force and they gave us the word extension. So we are looking for the one that contains force and extension. Is it this? No, it is not. There is K in this one. Is it this? Yes. This is what we are going to use. So very, very easy. Let's draw a box here and use it to solve this particular problem. Okay, stay with me to the end of this video. You will know physics by now. Let's do this. Our energy will give us 1 over 2 F E. So you have 1 over 2 times F is what? 300 times E, which is 0.005. Can 2 cancel 300? Yes. You have 150 times 0.005. If you multiply, you have 0.75 joules. Let's use my calculator to confirm if I am correct. Wow, wonderful. That's 0.75 joules. Is the answer A? No. Is the answer B? No. Is it C? No. The answer is what? D. Wow, that's so interesting. So take it. I'm not solving this question just to solve. I'm using it as a medium to teach you in details how to solve problems involving energy stored in a string. Let's create a space for ourselves for question number 2. Wow, a load of 5 Newton stretches a string by this extension, okay, in a wire which obeys what? Hooke's law. What is the extension caused by a load of 20 Newton? Wow, very, very easy. Remember that Hooke's law states that the force applied to an object is directly proportional to the extension produced, as long as the object does not lose its elasticity, or as long as the extension does not lose its elastic word limit. Okay, so that we have F is equals to KE. By the time you remove your proportionality sign, you put your equals to and put your KE. So therefore, you find out that K is equals to F over E, and this same K is what? Is constant. Wow. So therefore, we are having that F1 over E1 is equals to F2 over E2. So whenever you have 2 forces applied to an object, certainly the forces are not the same. They are going to produce different extension. That's why you have your E1 and your E2. Or we can say M1 over E1 is equals to M2 over words E2. Wow, very, very easy. So it's either we work with this or work with this. Please, you don't have to convert from centimeter to meter or meter to centimeter. The reason is because if the first extension is centimeter and the other is in centimeter, both units can cancel out each other. So you don't have to worry yourself to convert. Now, let's solve this question. We aren't going to use this because they gave us forces. So the first force here is 5 Newton. We put it over the first extension is 0.56 equals to the second force is what? 20, and the second extension is what we are looking for. So what do we simply do here is to cross multiply. So 5E2 will give us 0.56 times 20, and then quickly divide both sides by what? By 5, so that this what is E2 will give us, if you multiply this together, you have 2.24 centimeter, and I think I am correct, but let me use my calculator to check. 0.56 times 20 divide by 5. Wow, I'm correct. Very, very correct. 2.24 centimeter. So answer is not A, it's not B. Our answer is what? C. Wow. Let's quickly go to question number 12. You have the semiconductor device used to convert AC to DC is what? Remember, AC is called alternating current. Remember, your AC is called alternating current, and your DC is called your what? Direct current. And alternating current is a current that varies with time. It's a current that moves in a sinusoidal manner so as to reverse its direction periodically. So it's an unsteady current. But your direct current is always very what? Steady. So what do we do, class? Very easy. How can I convert AC to DC? Wow. To convert AC to DC, we need a device called a diode. The other name for a diode is called a rectifier. So a rectifier or a diode convert your AC to your what? DC. Wow. Is it possible to convert DC to AC? Yes. You can convert a DC to an AC by using a power inverter. Or use what we call oscillator. Wow, so interesting. So we can convert AC to DC by using a diode or a rectifier. The process, please write this note down. The process of converting AC to DC is called rectification. Write it down. Hope you have written it. It's called rectification. The process of converting AC to DC is called rectification of current. So rectification convert AC to DC, and the process of converting DC back to AC is called oscillation. Take note of that. AC to DC is called rectification, and your DC back to AC is called oscillation. Wow, we've come to the end of today's video. Though we have a lot of questions to solve, we are going to pause for now. I have one more question for you that you are going to take as your assignment, and please do not fail to send your answers to me on the comment section. Thank you very much. Let's take one more question for you as an assignment. Hello. Now, the frictional force that must be overcome before a body can start moving is called dash. I'm going to leave this question for you to do. Please, by the time you are done with it, send your answers to me on your comment section. Thank you very much. Remember, next week Sunday, we are going to send the other part of the questions, and we are going to be doing batch by batch until we come to the end of the JAMB mock questions, both in physics, in chemistry, and in mathematics. So if you have not subscribed to this YouTube channel, if today is your first time for coming across the channel, please do well to subscribe, and also help us to like and share them. Just share the video so that everybody could see them. Thank you very much. I'll see you in my next video.